So we give another 1 or 2 minutes maybe for more people to arrive. Can you hear me all well? All good? All right, let's get started slowly. So thank you for coming. My name is Sergey. I'm a software engineer at Meta, working on Presto team. And the last few years, we've been working on Presto C++, which has code name Prestissimo. And you can also hear Presto native. It's all the same. And today, I'll tell you a story of how we deal with adopting Presto C++ inside Meta, so we can run all the queries on a new evaluation engine much more efficiently. So about 1.5 years ago, travel back in time, it's May 2023, we started looking at the batch workload. So by this point, we went into production with one particular A/B test framework workload. It was an interactive one. And I think around mid-May, the first cluster went into production. And interesting story that we immediately kind of got it going down because we went to production at the peak hours. And it immediately got like a huge query queue. And we had to turn it off and went to production again the same evening when the queries were not so many. And since then, everything was fine. So 1.5 years ago, the workload was very well known. It was stable. The query shapes were the same. We closely worked with the customer team. So any kind of changes they did, we were aware beforehand. And we ran shadow, and we make sure everything works fine. So it was fairly easy to stabilize the workload and fix all the issues because there are no surprises from day-to-day runs. The main difficulty was that the VLX was not so mature as it is now. Right? I think even before we went to production with this workload, we started to look at the batch. We spin up one cluster and started shadowing the workload to see what we've got, right? So batch workload it's not interactive. It's all sorts of queries. They can be extremely large, running for a few hours. They can be small, running for 10 seconds as well. Tables can be very wide, like thousands of columns, or some columns can be really huge, like huge vectors or maps, and even like completely arbitrary structures. Also, we have about 12 million queries per day. So this graph is showing like a 6 hours buckets, roughly around 3 million. As I mentioned, like wide variety of query shapes. So customers pretty much send anything in there, all sorts of data types, and pretty much all the functions that are available in Presto being used as well. Some more often, some less. As also new queries are coming daily. And the existing queries like pipelines, right, they can change over time as well. On top of that, we have 10 regions, right? We have data centers, and every region has 1 or 2 data centers. And the different tables, they live in different regions, or at least used to be. I will come back to this. And when the queries go to one region, they usually go to the certain set of tables. And if you go to another region, you will have completely different set of queries and the tables. And we only had one cluster, right? Means one region. We took the biggest one, I think, which was about 28 Presto clusters at the time. And whole 10 regions had slightly more than 100 Presto clusters. And Presto cluster is a coordinator, or in case of multi-coordinators, 3 coordinators, and hundreds of workers, right? Can be like from few thousand, like 300, usually 600, and was 1,000 workers as well. So how would one try to, bring a new evaluation engine to this world, right? And we cannot just spin up a lot of test clusters and start shadowing a lot of workloads and get the signals from it, because there's just not enough hardware for that. We only had one at the moment. And I remember at that time when we started, the success rate was about 50%. So half of the queries were failing. And the cluster went into some kind of disaster state from time to time. So Shadow, right? Shadow is like we've been using for all these years. Shadow the production workload. This gives you the best picture. Right? It gives you the real-world queries, real-world data. It gives you the dynamics as well, the peak times and the low times, right? So you can see how your cluster will maybe struggle at the peak times. It gives you reliability and performance signal as well, because when we shadow query, we can actually match it with the original query and compare the performance apple to apple, right? We can do this average and whatnot, P90. First, of course, when you have unstable cluster, then kind of performance signal is lost. You cannot compare much. So the first priority went into the making sure the cluster is always operational, right? Making sure there's no deadlocks or distributed deadlocks and crashes, or like some slow running queries that hog in the threads or CPU and not letting others run. And there are a lot of interesting issues we encountered, like for instance, distributed logs when you have like a remote exchange, and the consumer is waiting for producer for some reasons, and producer is waiting for consumer. They wait on each other and wait forever, and they just block everything eventually. Or some exchanges were extremely slow, like trickle like one row at a time for different reasons. Maybe rows were big, and were taking forever to complete. Might is like equivalent to logged. Crashes were all over the place as well. And we didn't even start looking at correctness at that moment, because there were so many different stuff. At that time, since 50% of the queries failed because of different reasons, and one of the prominent reasons is just no functionality, right? The function is not implemented, or maybe even operator not implemented, or a certain feature of connector which goes and fetches the data from the storage. So a lot of folks started working on that to bring it up, to bring percentage up. What was interesting, even it was one cluster, right, in this region, and native C++. And we had 28 actually real ones, right, Java, that we were working in production. And we shadowed only one. And the workload was very different. So one day can be like success rate 50, another day 80, and next day 30. It was super unstable, because we only had roughly 1/30 of all the queries coming in, even in just one region. So yeah, as I mentioned, we tried to fix all the reliability issues, because we cannot work on anything else if we don't have a good signal how the system performs. A lot of comms errors were also encountered, like workers become unavailable for some reason, like coordinator loses them, or cannot talk to each other as well. Those were really hard to track down, and some of them were kind of easy to fix with certain settings, like timeouts there are different timeouts in the Presto with the config options and also session options. Those need to be adjusted, and some bugs fixed as well that causes comms errors. Comms errors mean a bunch of queries just suddenly which were running at the moment, they all fail, right? It's a lot of queries. In flight will fail. It's a batch workload, so many queries will just use a lot of memory, and some queries wouldn't even run unless you spill it, right? No matter what you do, they still need to use more memory, so you need to spill it on disk or some kind of remote storage, temporary one. And that caused us to really pay a lot of attention on memory management system. We had one in VLX, but at the moment it wasn't very mature and spilling wasn't implemented. So a few folks are working on that, like pretty much all the time during the batch development. Now it's in very, very good shape. So adding missing features as well. Whoever could pick something up, we had all the, we had a good dashboard which was showing what kind of functions are there, what kind of functions implemented in Velox, and the frequency, like how many queries using certain function, and also like how much CPU this query is used. So we took the most important one, right, most impactful one, and implemented first. Started paying at correctness at some attention at some point, right? For correctness, we were using Presto verifier. Have some verifier cluster, which is Presto C++, and the source of truth, the control cluster, is a Presto Java, right? And have some queries run for the previous day, a certain percentage, because we cannot run them all, and run the verifier and compare the results. So in the beginning, there were like hundreds of issues, of course, and we didn't pay attention on any kind of errors. Started looking only at the column mismatch and the row count mismatch. Performance also had some attention, and we didn't really spend too much time on that, like really perfecting and making sure that all the queries run faster in Presto C++. We picked up the worst ones, right? They're like really like, there were cases when the Presto C++ was like 90 times slower than Java because of some really interesting problems. So solve those ones, and when you solve one issue, it kind of makes a wide variety of queries run faster suddenly, right? So we kind of tackle the most prominent ones, and there's still some queries that are running slower in C++, but those are not that important. They can be like small enough, and it's a batch query that runs like for 30 seconds or 40 seconds. Nobody really cares in the end. Okay, cool. So we're improving the system and getting better. We reached up to 80% around October, right? But how do we go to production, right? How do we run some queries in production? So we cannot just run a query and hope that things go well, right? So how do we make sure that it's 100% correct? Because we don't want, most of the batch queries, they insert queries. So they write a table, right? And if there is an incorrect data in there, it propagates. People start reading, and maybe like they also write in more tables, and it's really huge impact, right? Reliability was still having issues here and there. And we're also looking at only one region. And what about others, right? We haven't even tried them. And as we found out later, and we expected that when you run Shadow in another region, you have totally different problems because it's a totally different queries. So we looked at what we have in Meta. So in Meta, inside, we have the pipeline like infrastructure. It's called Data Swarm. It's a system that allows data scientist or anyone basically write the pipelines and have them running regularly, right, using certain cadence like a daily, weekly, or even hourly or 4 hours, or maybe when the data is ready in the upstream. So, and this pipeline system had certain qualities that we could use to just identify which kind of queries are good and run only them in production, right? So we had a chance to not just run query and hope everything goes right. We have a chance to say, okay, this query is 99.999% gonna run fine, right? So we can run it on native cluster in production. So 65% of all the batch queries are pipelines. So that's a good impact. If you could run them, that's already 65% of all the batch. Awesome. As I mentioned, the system, we can identify query in the system, right? So particular pipeline query is identifiable by the pipeline name, by the task name, and also there's like a hash on the query itself, not taking into account the dates and whatnot. So we can detect when it's actually changed, and then when it's changed, we stop running it until we make sure that it's correct again. And also pipeline queries don't change too often. They do change sometimes, but many of them run as is for like long time. In addition, the pipeline framework had this client code that eventually calls the Presto client and goes to Presto, right? Runs the query, get result. And it means that we actually can run added custom code in it, right? That has some logic. Do we run this query in native or not? So we took this idea and we come up with a certification framework, right? So it basically takes a bunch of queries from the previous days. It runs from verifier. The queries that succeeded in the verifier, we certify them, make them green. And the pipeline, the data swarm client, then can check if the query is particular query that we try to run in production, right? The pipeline query, if it's certified or not. And if it's certified, we add a special tag to a query. When we send query to Presto client, we can add some tags to this query, client tags. And we add like a native eligible tag. And then Presto Gateway, it's a system and method that basically it's a router, right? Query router. So when a query comes, the Presto Gateway decides which region this query goes and eventually which cluster it goes. In the Presto Gateway, there is a code that can check the tag, right? And if it's native eligible, it can send query to a native cluster. So, for example, if a query comes and query can have to run in certain region, and there are like 5 Presto clusters in there, and one of them is Presto C++, and the query has a native tag, then this query can actually run on Presto C++. Right. Also, in the pipeline client, if the query failed for some reason on native, right, we can retry this query in a Java cluster by removing the tag and make it and run in Java. So that's another benefit, and it was very useful because some queries could fail for some reason. As we turn out, like as I found out the later, this identification of a query in the pipeline system was not completely bulletproof, and a lot of things were not clear. And we could run a query, we could make a query native eligible when it wasn't truly certified in some cases. So in April 2024, we went to production with this system, right? So we had one cluster. Okay, so in the pipeline system, we have 5 tiers of pipelines. Tier 1 being very important ones, and they have very tight SLA in terms of how long they should take, how fast they should land, right? And tier 4 and 5 are less important ones, and they can just run whatever till the end of the world, almost. So we look at the tier 4 and 5 first, right? So if anything goes wrong, there's going to be a less important disaster, right? Less dramatic. And we spin up one cluster production, Presto C++, and start running the certified pipelines, right, in it. So this picture on the right, it shows you like the tier 1 to 3 were not running on C++ at this point, right? The tier 4 and 5 we're using like a traffic light, right, if it's certified or not. And in addition to that, we have a certain templated or programmatic event queries running in the batch as well that basically almost never change. And we identified certain workloads that were simple enough and were always succeeding. And we also added a special code that checks, okay, if this is like from this source coming in query, right, we can green light it. We make it native eligible. So we spin up another cluster to run just that templated queries. So that reflected by this script icon, and they can just always write there. At first, there was not much traffic. We had some investigation of how much traffic it will be, and we expected a good amount of traffic on Presto C++ cluster, but a few things went wrong a little bit, and we did notice few aspects of the infrastructure, and we didn't have much. In addition, at that time, changes were happening in the meta infrastructure, right? So one of the changes that started this year is to make tables not to live in just one region, but make them multi-region, right? What that means is you have a query that was running in one region, we certified it, and we're hoping to run it in native, but it doesn't run there anymore. It starts running in another region, and we kind of lose it, right? And other queries come from another regions which we didn't certify, and we couldn't run them. So that reduced the number of queries we can run. And also, like ID of these pipeline queries were also tricky, and it was changing, and we wouldn't mark native eligible the queries that we actually certified because of the certain differences in IDs. But it was still good, right? We were running certain percentage of the queries in production of batch queries first time. That was a interesting story. Okay, great first step, right? So those are little things, little icons in the bottom. Those reflect the Presto C++ presence in 10 regions, right? We have one by April 24. Okay, so verification is very noisy, right? So means like a lot of non-deterministic functions can be there, and we had to fight with them. How do we, like, it can be correct, right? Because it's non-deterministic, there is no single right answer. There is also different behavior in Velox and Presto. Most prominent is when you convert a double to a string, right? They produce kind of same double, but it's slightly different, and that is kind of a wrong result from the perspective of verification. And how do we deal with this? We worked a lot of improving the verifier, reducing the noise, doing some replacements, right? Equivalent replacements of the query parse. Like one function, for example, if there is a function that creates an array and it's sorted in a Java and C++ differently, and we can just add like array sort on top of it and run it in the verifier to make sure that in the end arrays are compared correctly. And we introduced like a retest functionality that runs a query, okay, and it detects a certain like string column is different, varchar column is different, and then it goes in and replaces like some cast double to like round and create string again and see if that's correct, and if it's correct, then it marks it as resolved and good. And some other tricks which greatly reduce the noise. We've been having like dozens of issues per verifier run before, and these days we have just, few to several, right? Under 10. Sometimes even 0. We exclude like completely non-deterministic queries. Like for example, if you do like a select whatever and limit 10, right, and there is no sorting, it can produce different rows. So those are not being tested. As I mentioned, that query identification had some problems. So, and when we find a bug, for example, and then we probably need to go and decertify all the queries, and then stop running, and then by the time we certify them again, we don't run anything. And also, when you certify it, you need to certify it for a specific version of Presto C++. There are like a lot of problems. On top of that, the verification certification doesn't scale because you need to run a lot of queries every day to just certify them, right? There are 10 regions, and you need to have at least 10 clusters. That's not going to be enough because you only can run a like small portion of that. That we partially remediated with a scaled verification when we reused the query results from production. So we didn't run production query again. We just took the results and then ran in C++ and compared them, which saved a lot, like allowed us to certify more queries and increase their presence. So, but anyway, that's was just for the first step, and we cannot continue like that. We cannot like move forward with the certification approach, and so we come up with the idea to have a block list approach, right? So first requirement would have been to make sure that we don't have any correctness issue that we cannot control, right? If there's a correctness issue, we block certain query parts, and that's it, right? And we only allowed to run the ones we know that are stable, right? That are correct results. Then we enable all the pipeline queries by default, right? So we make them native eligible. And if they fail for some reason, we just retry it in Java, right? And we have this block list that can be changed really, really quickly. When we detect a problem, we just go and submit a change, and it lands within like half an hour to block certain queries with certain functionality. We can block with different functions. We can block queries that have certain substrings, like maybe some patterns in the regex functions, or can block queries from certain sources and to certain tables. So just to make sure we can protect whatever runs wrong really, really good. So no correctness issues we don't control, right? So how do we make it happen? That all the queries we know that run fine except for something that we block, right? So that 10 regions, right? And as I mentioned that all of them have different queries. And so we went to very straightforward approach. We started running a lot of verifiers. I think we spin up like 6 clusters in 6 largest regions and started running daily verifier and threw a lot of engineers to basically triage it, right? To come through all the issues and create the tasks. And if there's a function problem, we just block this function. We have a task for it until it's fixed. It's blocked. If there is actually a fundamental issue, like for instance, join having a bug, right? So we try to fix it like straight away, really quickly, and roll it out. And we continue also to denoise the verifier as well, because it still has a tiny bit of noise, but it's almost none. It's really good. Yeah, we also to facilitate the triaging of the verifier issues, right? We created like an ad hoc text database of the problems, like with the columns and tables, so you can quickly look up, like when you see some kind of column mismatch, you can look it up if it's already known one, and don't spend too much time on it. That helps a lot. And we thought initially, like from May, we thought in the middle of June we can be really good, right? We planned only for 1 month, and that was too optimistic. It took 4 months to actually come up to this state that no correctness issue we don't control. Interesting at this stage, like multi-region move was like going more and more, and it actually helped us because these 6 regions we were running verifier start having all sorts of traffic, even from the regions we didn't have access to, right? So that allows us to expose more queries, but it also created more issues for us as well. So in September, we reached to the stage where we started running tier 1 and 2 in certification mode because we don't want to create really bad SEVs, right? Important queries. Tier 3, 4, and 5 were finally enabled all the time, and they had a chance to run on C++ straight away, and retry it when failed in Java. So most sources, like programmatic or hard-coded sources, were enabled as well that we identified are really, really stable. We're using the block list to block anything that is not running correctly, or also not running anything that we don't support, because in some cases retry was also bad for customers. They started complaining that the queries retry, they take longer time, and we block those as well, so they run straight away on Presto Java and run fast. Okay, so and we also roll like more Presto C++ clusters in more regions. Like you can see there's 3 regions already at this moment, and not just one cluster, but few. One of the reasons we cannot like roll out more is because of the hardware is not exactly like a lot of it, right? We cannot use it everywhere, and it's not free. And also, if we start converting Java clusters to Presto C++, it can create a separation when all the like Java only queries go to Java and the C++ only like go to C++, and some of the clusters can have like a lot of queues. For example, the queries that are not eligible, they just start piling up on Java clusters and create a lot of queues that are longer, and this will impact negative impact for the users. So we have to be really careful rolling out new Presto C++ clusters because we don't control flexibly which runs where. And also another problem that is prominent and worth mentioning that certain sets of functions are extremely hard to make right? Like JSON functions, like JSON parser, JSON extract, regex functions, URL functions. Those are having really huge differences in C++ world and in Java, and make them run the same way is really hard. It's not like even semantical only differences, there are functional differences as well. Certain things return completely different results and some not supported. There is a lot of work going on right now to make it similar or close enough so we can migrate. Okay, so current status. As of November, we had only tier 1 using certification. All the other tiers are running initially native eligible and being it right. More sources enabled as well. And I think this week or next week, we're going to be enabling tier 1 as well. So we're going to be running all pipelines as a native eligible. And that also allows us to more freely convert some Java clusters into the Presto C++ clusters. It's also worth noting that when we convert a Java cluster, currently Java cluster batch 1 has 600 machines, workers. We convert it into 2 native clusters, 300 each, right? Because native is so much more efficient, it can run on less hardware and gives you more opportunity. It reduces the queuing as well. But we want to go to the next stage, right? We still cannot enable everything. We have to control things, and we have to do this native eligibility, right? And we need to have a general enablement where we can run everything either on native, if it can run on native, or on Java, if it can run on native, right? And that's where the work in Presto DB comes in handy, right? The new SPI, I think version 2 protocol, right? That's how it's called. When we're going to have a sidecar with a Java Velox sidecar, which we can give the plan, and it can tell us, okay, can Velox run it or not, right? And we plan to use it on the router, like a Presto gateway. So when a query comes on the Presto gateway, no more native eligible or native only tags. We can just ask Velox straight away there. Okay, can you run it? Cool, you can run it. So then we send it further and it has a chance to run on native. So that will be like general native enablement. And then we don't have to worry about all these tags and how do we, identify the query. Yeah, and then we can convert more clusters in next year, early next year. The first half we plan to have like majority of clusters Presto C++ and a few Java to run whatever we cannot run on Presto C++. And eventually we want to run everything on Presto C++ as well. We also started looking into interactive. Actually, even a year ago, we started looking into interactive ones, but just like to see where we are, right? Interactive queries. We're actually in a good position there, but some performance work needs to be done because interactive they are very performance sensitive, and we cannot just say, okay, it's 40 seconds instead of 30. Who cares? It's a batch. Here we need to be fast. Functionality long tail, as I noticed, as I mentioned, that's going to be an interesting thing to cover. So Presto C++ can run everything. Coming back to the previous slide, so this graph shows like green one is a native eligible right now in the batch cluster. So it goes all the way to 75%. You can see every day how it changes like this. This is how like dynamic workload in batch is. Very interesting. And the blue one is actually how many queries we run percentage-wise in C++ clusters out of the whole batch. You can see we're close to 50%. This is our goal for this half, and sometimes even higher. And it's like changing over time because of the workload and because we also block this and we then enable this. It's almost every day some kind of change going in that affects these dynamics. Yeah, the bottom line is like 30%, right? So don't think that we went to zero somewhere. For like several weeks or maybe even a few months, we're not running less than 30% queries in production. And we currently have presence of Presto CPP in all regions. That was actually requirement for one of the use cases, which is kind of separate batch, very important use case, ad related, which went to multi-region, and they have some queries that can run only on Presto C++, and we had to go everywhere to accommodate them, which is good, which basically accelerates us going forward to production. Right, okay, I'm a little bit over time probably. Thank you for your time. Hopefully it was interesting. A little bit maybe mixed up. It reduces hardware used, and it also reduces energy use. The most impact is how much, like, you use much less CPU, right? Like 3x we're observing is minimum win in most of the queries. 3x less CPU.
So when you convert a Java cluster to Velox, so you said 600, you convert 300, 300. You could have just saved some costs there itself, right? So how do you plan on doing that?
We plan not to have so many C++ clusters in a batch, right? As we go further, we're going to have surplus, right? And we return it to the infra, right? And they can be used for something else. And that's going to be like a company-wide impact.
But don't you think that initially having more C++ clusters will run more queries, and after once you remove, the queue will build up in future?
Well, it's possible, but we're not going to just remove all of them, right? We're going to be one at a time and see how dynamics change, right? And we also have to be aware of some, like a high throughput times, right? When like in the end of the year, like many more queries, right? We need to make sure there is always like a buffer, right? So we don't go into CFs. Oh, sorry, yeah, you.
How are you managing the platform independence when you are changing into C++ binaries? Why? Because different operating systems has got different GCC, flavors.
Oh, yeah, we have an internal infrastructure in Meta, which basically builds things uniformly. If it's like a C++, right, for example, and Java, it's built also like internally, and so on. So we don't have to worry about it. So we have.
When you are publishing it for the open source community.
Oh, okay.
How do we download it and how do we execute it? That will be the problem.
I see.
We have Docker images, community Docker images for C++, and we also have a Helm chart, if that helps.
Yeah, I believe some of the sessions will be how to use, right, and install the Presto C++, right, today.
There was a workshop yesterday.
Or maybe
yesterday.
yesterday.
There are lots of helpful folks here who can.
Yeah. There's like a general Slack. You can always ask question there and then maybe redirect it to a particular Slack. Yeah. So, or reach out whoever you know in Presto. They should help you to find a person who will know. Sorry. Yeah. How do we verify for non-deterministic? So some non-deterministic functions can be replaced by deterministic. For example, a prox distinct, right? We just replace by distinct. It's more expensive. It's very kind of, but that we just get a solid number, right? There are other tricks which, well, I'm a bit unprepared for this answer, but basically we look at the query text, right? It's not super ideal. Ideally, we would like to have like a tree, like a operator tree for the query, right? So we can actually replace the subtrees of it. But currently, it's in a verifier and it doesn't have the operator tree. And we just look at the text replacement. So we look at certain patterns, like a function name, right? And we can replace it with another set of functions, right? And even like maybe different arguments as well, right? Which remove determinism, right? For example, like I don't think we actually replace random. Certain non-determinism we cannot replace, but others, if you're interested, I can maybe follow up like right after and try to find the what we can do. I believe verifier is a part of the Presto DB, right? Yeah, it should be all there actually. Or is it? Maybe not. Maybe we use a PT tool, Presto tool. that can have this possibility.
Some of that work is in open source. It might you might want to get some help though because
Yeah.
There was a talk last year, last Presto which answered this particular question.
if that's the case, then there's a video for that.
Yeah.
So you can actually go to the last Presto and it actually talked about how we verify non-deterministic.
Was it like summer or last summer, right? PrestoCon day. Yeah, that makes sense. Yeah, let me ask some folks who will know where it is, and I can follow up with it.
Besides these batch queries, did you try public benchmarks like TPCDS and do all of the run?
I think IBM doing a lot of that stuff, right? TPCDS benchmarks.
We are doing also TPCDS runs. I believe we do them at least weekly. We fix there's still some issues though, like because TPCDS uses data types that are not supported, so like you won't get like one-to-one. For example, the character type, like that's in TPCDS, and Velox doesn't support that. But in terms of performance numbers, we run those in open source periodically. We see really great results in the eval, but like there's some work to do in the optimizer.
Mhm.
Sergey, sorry, we gotta move. I think we
Yeah.
gotta move to.
Yeah. Thank you, guys.
Okay, is this loud? Okay, great, I can hear it. All right, I don't have a whole lot of time. I got a lot to cover, so I'm gonna be quick. If I'm going too fast, just let me know. So what I want to talk about, sorry.
Not up yet.
Okay. While this is going on, I'll just kind of like talk